Hello again, folks. Today we're going to be covering section 10.1, percents. The calendar, just to show you where we are. Today is Thursday, February 4th, and we're covering, according to schedule, section 10.1. All right, let's see, which is the last section before what would be the test. I'll tell you about that on Tuesday. All right, in between now and then, don't worry about it. Just do your homework. Let's put this out of the way. Don't lose edges. The packet that I have for you today, things, looks like this. It is this diagram that I'm going to have projected over to here because I want to add some things. Alright, this is how to convert between fractions, decimals, and percents. You may have to do that at some point. And then a couple of extra formulas. One of them you technically already have, the percent of change formula from a couple of weeks ago, well, last week. This is a nice formula for markup. And these are procedures in case you're not really happy with my own explanation. This is taken straight from the textbook. And then we'll do the examples. Okay, so print that out, at least the examples, so we can go through that. And you can follow along here. Let me fire up the projector and adjust the blinds. Yeah. Come on, there you go. Green light means good. I'm gonna close this. I had the good sense to put up a curtain. Hopefully this isn't too dark. There are my glasses. And not too out of focus. This isn't quite aimed correctly. So I'm going to scoot this over here. Zip, zip. Not quite fast, but maybe adjust the keystone. I'm not loving it. And I'll try to see if I can get this to focus just a wee bit better. That's okay. It's not great. That seems to be as sharp as it's gonna get. All right. Okay. What do you want for $60? That's how much I paid for this projector. As always, if you need to go through Canvas to get to these copies, you can do that directly through Pages. We're doing chapter 1, 6, and now 10.1 is the only section from 10.1 from chapter 10 that we're doing, but I haven't posted it yet. It will be underneath the last thing, 6.4, and a couple of more PDF files here. I have them on my desktop, so let me pull this up. Okay. Let me get a paper towel too. Alright, we're in section 10.1, as I mentioned, the only thing from chapter 10 that we're going to be covering. Here's a little information. Alright. A couple of things. A percent is a ratio, right, which means essentially there's an obvious top and there's an obvious bottom. Right. It's a glorified fraction for all intents and purposes. I wonder if this blue writes a little bit better. Yes, just a wee bit. So maybe I'll use this instead. Okay. It is Latin, this word, percent. It means per cento, I believe is the centum. Sorry, my Latin is a little rusty. And that literally is per 100. So if you have some inkling about translations from when we were discussing word problems, what per means. Per implies that you're dividing. We would use this style of division, this line, the sort of fraction-esque line, when we're talking about a percent that is in the ratio style, the fraction-esque style. So it would be something over 100, right? Which is cool if you wanted to convert to a decimal, because it would tell you literally where the digits go. If you see 100, that is referring to the hundredths place, right? Which would be 2 digits after the decimal point is the hundredths, right? And right here would be the tenths, right? Just like this would be the ones place, and so forth, right? And then the thousandths would be after that. All right. In a nutshell, and I may erase this just for the sake of space. I don't want to move the projection so much. Hopefully this is visible. When you convert, regardless of what you start with, right, decimal or fraction, right, if you're converting to a percent, right, just recognize that you need to multiply by 100, right? If you're going to convert from a percent, that means you're going to do the actual division, right? Not just simply write it as would normally be the case, just simply write it over 100, whatever the number is over 100. When you are going from starting with this, you're going to divide. When you're starting with this, you're going to it rather, you're going to multiply. Now, just to make this a little bit more clear, maybe I'll blow this up. Ba-boom. And move this over just a wee bit. There we go. There's actually a word for this shape. Right? I don't want to bother you with trivial facts, but it is kind of interesting. You see, the way that I drew this diagram, I didn't do this intentionally, but it's sort of a triangular shape, right? There is a word for that, Roylow triangle, that's curved outward. And then there's this sort of concave triangle on the inside. There's a word for that too. It's called a Fratzog. Anyhow, this summarizes pretty much everything that you need to know when you are converting between one of these three styles, if you will, of a number. All right, I put these dots here to emphasize that that is where you're starting, and this is where you're going. Okay, so if you're starting with a decimal and you're converting to a percent, all right, as I mentioned, if you're going to a percentage, you're going to multiply by 100. Now, when we're talking about a decimal, the effect there is that you would basically move a decimal point twice to the right, which would mean that way, you know. If, on the other hand, you're starting with a percent and you're going, as you're starting here and you're going here back to a decimal, you would be dividing by, that is from, you divide. The effect in terms of a decimal point would be that you move twice left instead, which would be that way, you know. I hope that that is visible. Left. To the left, to the left. Okay. Okay. So either going twice right, that's times, or twice left, that is divide, the decimal point. All right. In theory, if you are converting from a percentage back to a fraction, it's the same thing. The effect is not maybe as obvious, but it might actually be easier. You are still, if you're starting from here, that is from, and you're going elsewhere, that is either to a fraction or to a decimal, you are dividing in either case. Okay? If you're going to, starting in either case, to a percentage, then you are always multiplying. Okay? I guess perhaps it would help. I'll put a little notation here. When you are starting with a fraction, right, and you multiply by 100, the effect is that there's a cancellation. Right. A sort of cross cancellation of 100s. Or something like that. I mean, you might simplify a fraction that doesn't have 100 in it, but if it starts out that way, then you will see it. Right? When you're starting from a percentage and you're going to a fraction, you are nonetheless still dividing, which is why I made this blue. Right? The effect is that you basically are going to end up having to write whatever the number is with a 100 underneath it. That's kind of a cheat, right? It's a cop-out in that, well, you're dividing, but not really bothering, you're just more or less superficially dividing because you're writing this line and then 1 and 2 zeros. Even the symbol itself, that is the forward slash and the 2 O's, it really is simulating 1, 0, 0 without drawing it correctly. Now, you may not have to do this too much, but I put it here anyway because sometimes it's a convenience for you. If you have to convert from a fraction, there's the dot again, that's where you start, and you convert from a fraction to a decimal, this is really all that you need to know. You're going to divide the top number by the bottom number. Okay? If on the other hand you're going the other way, if you're starting from a decimal and you're going to a fraction, this is where you would take this into consideration, right? If you had a number like, let's just say 0.15, right? Think about it in a more verbose sort of way of speaking about it. Rather than saying what would be clear, 0.15, anybody in a chemistry class would probably be okay with that. It'd say, how many milligrams is it? Oh, it's 0.15, or some other unit, right? If you wanted to be fancy, you would say it's 1500ths, THS. Hundredths, all right? But saying it that way, however peculiar it is, it's English, and English is filled with peculiar expressions, right? The places, if this is 1500ths, implies what the denominator is. I don't know if you can see me because I'm out of the frame here. Just barely, right? That's 15 sitting over 100, literally. Right, which is already a percentage because it has a denominator of 100, which means you could easily convert it if you needed to. All right, the homework, just having analyzed it, right, seems to be doing this much more so. These two things, converting between fractions and percents and decimals and percents. Right, but sometimes it's a convenience to do this or this first, right, which is why I wanted you to have it. Okay, so we'll do a couple of examples now. Let's see. And you'll get your feet wet. Now let me turn off the projector because it's a bit dark. All right. Let's see. And fix the blinds here. I think I could put this down. Water here. Alright, now I want to spend the balance of time basically going through these examples. at least the ones that I've included here. Starting with this 1, of course. All right, which has 3 things. All right, let me see if this is in the frame. Looks like it's okay. Might just move that back a smidgen there. That looks good. Okay, good. Here's example 1 in 3 parts. All right, there's a part A, a part B, and a part C. All right. And you are asked to convert from what is given here to 67 over 100, 11 over 20, and 15 over 16. With all evidently fractions, you are asked to convert to percentages. Now, a couple of things. You can do it directly. You can go from this style of the number, the quantity, to this style of the quantity. All right. Alternatively, and sometimes it's more practical for you, you could convert the fraction to a decimal first, and then convert that to a percentage. Right. Right. So there's a direct path and there's an indirect path. Okay. To the same outcome. Right. This one is a perfect candidate for direct path. Just to put this back and refer to it. Right. As I mentioned, if you look at this sheet, look at what you're starting with, a fraction, and you're asked to convert to a percentage. That implies that you have to multiply by 100. You start here, you go here. So, in doing so, you would multiply by 100. Now, if I'm treating it like it's a fraction times a second fraction, I just might stick a 1 of this to be proper. And then look what happens. There would be naturally a cross cancellation effect. Right? This would cancel this, right? And because you've multiplied by 100, you'd be left with 67, right? But it's 67% at this point, right? You can do the same thing here, right? 11 over 20, right? In which case, if you did, it's not going to cross cancel exactly, at least not without some adjustment. But you can cross simplify, right? You may recognize that the number 20 and the number 100 have a common factor, namely they're both made of the number 20. And even if you didn't recognize that, you could whittle it down slowly by recognizing that this ends in a 0, that ends in a 0, they're both divisible by 10. Right? The GCF, which would be the most efficient way of simplifying, would be to use 20 though, because that's the greatest common factor. 20 divided by itself would be 1, right? Just like 100 divided by itself would be 1. 100 divided by 20 would be 5, right? 5 times 20 is 100, right? There's just ones on the bottom here, you don't really need to pay attention to them, but if you multiply across the top, you'd end up with 55, right? Which is now a percentage. Okay. This one is not going to simplify nicely, right? If you tried to do it, you would get something that's pretty close, right? But you're still going to end up with a denominator that's not 1. So I'll show you, right? Put this in red. These are both made of the factor of 2 because they're both even, which means you could cross simplify by dividing each of them by 2. That's not the best choice though. The GCF, the greatest common factor, that is the number that they have in common that they're both made of, is actually 4. All right? So if you just went with that, it's again, just realize it's not going to leave you with a 1. So you're going to have a denominator, at least at first. All right? 16 divided by 4 is 4. All right? 100 divided by 4 is 25, right? You can't simplify, unfortunately, more than that directly. So what you would do is go, okay, what's 1 times 4? You have 4 as a denominator. And then you go 15 times 25, which is 375. Right. And then you have a fraction, all right, that is an improper fraction. All right. What you can convert the improper fraction to, and that's what I'm alluding to at this point, all right, is you could divide the top by the bottom, right? And you will get a decimal, but it will be a whole number point something, which means that's really a percentage. So here's what you would do. You would write the little box here, or use your calculator, 375, and you would proceed to divide the 4 into 375, right? So you'd say, all right, 4 doesn't go into 3, it's too small, but 4 goes into 37 9 times, all right, which is 36, and the difference is 1, and you bring it down to 5, all right? And 4 goes into 15 roughly 3 times, which is 12, and the difference is 3, all right? And then I've kind of tucked myself into a corner here. You would include an extra 0 and bring it down, and then you keep going past the decimal point. All right, unless you're going to make this 3/4, which is also cool. All right, 4 goes into 30 roughly 7 times, which would be 28, and the difference would be 2. And then you'd have a second 0, which again I'm squeaking in here, sorry, ran out of board space. And you'd see 4 goes exactly into 20. All right, how many times? 5 times, which is 20, and it terminates at that point. Anyhow, what you would get eventually, whether you did it long division by hand or you used your calculator, all right, you would end up with 93.75%. All right. Why a percent? Because you multiplied by 100. All right. This over here is just converting it from a fraction style of a percentage to a decimal style of a percentage. All right. All right. Now, the alternative, all right, to a problem like this, all right, is that you could have converted 15/16 to a decimal first. That is, you started with this and you went here first, all right, rather than multiplied by 100 first, right? But you will get to the same place one way or another, all right? If you did 15/16, the only argument there is that it might be smaller numbers, so it's a little bit easier to deal with. Right. But here's how it would look. Right. This same problem. 15/16. Drop the 15 in the box here, put some zeros in, and proceed. Right. 16 will not fit into 15, right? It's too small. Alright, so you would put a 0 here to start with, and a decimal point just above the decimal point. 16 you'd have to estimate goes into 150, right? If this was 20 and that was 140, that would be exactly 7, so it would be 7 or larger. And you brute force try this. You'd say, well, let's see, it's 42, that's 112, that's too short. And try times 8, 48, carry the 4 is 128, too short. 9 would be the maximum, and it really should be. All right, 54, carry the 5, 9 is 144. That is as close as you're gonna get 144 without overshooting 150. Right? So this isn't the blinds here. It's a little dark, but it might be easier to see. Right? And then you'd subtract. What's 140 minus what's 150 minus 144? 6. Right? Drag down to 0. Do it again. Right? 16 goes into this. 3 times is 48. And the difference would be 12. Right? Drag down to another 0. 120. That's why I never feel bad about doing extra work. A lot of times you end up using those figures anyway. Right? It's already been established from trying to estimate here that 16 times 7 is 112. Right? And the difference would be 8. And then you have another 0 and you bring it down. And you'd say, well, 16 times 5 is exactly 80. Right? I'm cheating a little bit because we already did the calculation, so I know what to look for. But this is how you would feel around in the dark if you had to. All right, now look what you got here. You got 0.9375. Right? This is having converted a fraction to a decimal directly that way rather than directly this way. If at this point you are converting from a decimal to a percentage, whenever you convert to a percentage, what do you multiply by? 2% is times 100. 2% is times 100. The effect of multiplying by 100 without using a calculator is that you will move your decimal place twice to the right, which means that you will end up with 93.75% nonetheless. Okay? So there's often more than one way to do something in math. All right? Ultimately, do what you feel most comfortable with, but kind of save it in the back of your head. You have options. It's nice to have them, right? Let's see if this helps with that. That's a little bit better. All right, let me erase this. Number 2, the bottom of this page here, we're going to be changing from a decimal to a percentage. So we kind of already started the technique there, right? Yeah, there will be a part A once again, a B, and a C. And the figure you were given to start with is 0.14, 0.893, and 0.7625. Right? These are pretty straight forward. All right? And if you notice again, right, you're starting with decimals in this case rather than fractions, but you are nonetheless converting to a percentage. So when you do that, you multiply by 100, and the effect, without really thinking about it too hard, right, is just this. All right? You move the decimal place twice to the right, right? And then your answer is 14%. Right? Super easy, right? Times 100. The effect is you move your decimal place, times is to the right. So your answer is 89.3%. Right? Times 100, 1, 2. This is 76.25%. Okay. That's pretty lickety split. All right, now what if you had to go the other way? I'll put this under here, just not to have to erase it. This is technically example 3 here. There are, again, 3 problems to do in example 3. And what you are given is the percentage to start with. And this one is a trick kind of a question here. There's definitely an answer for that fraction percent, but it's still, and this is the hard part, you have to convince yourself, if you see that symbol, it's a percent, right? I know that there's a fraction tucked into it, but just like this has a decimal tucked into it, it is nonetheless a percentage, which means that the rules that we have for converting to and from a percent still hold, all right? Now, what they're asking you in this case is to convert, we gotta turn the page here, to a decimal, right? From a percentage, which is evidently what they are, notice the symbol, to something that is purely a decimal number. This is a decimal percentage. You want to make it just a decimal. This is a fraction percentage. You want it to be just a decimal, which means that there's going to be some either multiplication or division depending upon where you're starting. All right, notice this diagram again. If you're starting with percentages, and that's what they all are, nonetheless, we are going to divide by 100. Okay, and that's the trick. All right, now the first one is pretty easy. Right, if you change this symbol to what it literally is, put a little thought cloud here. This means divide by 100. All right, which means that it would look like that if you wanted to write it in the style of a fraction. If you wanted to go to a decimal, all right, start out with the placing the decimal point where it is to begin with, right? The decimal point where it is to begin with is technically there, right? It's one of those things, unfortunately, math people, for better or for worse, they leave out decimal points a lot of times, zeros, ones, right? And positive signs, right? If you are now dividing, because that's what this is telling you to do, the effect is that you're going to move your decimal point twice to the left. So this is really 0.35. Now, if you're wondering, like, well, a lot of times I see it as a little bit differently than that. The only alternative is that if you feel like it, and it's more as a formality than anything else, is you could put a 0 up in the front here. Right, that's for stylistic purposes. All right, it is supposedly making it easier to identify where the decimal point is, but that's arguable. Right? So it's a little hard to see green. I'll put a little phantom 0 in here. Right, you could put the 0 there, or you could just have 0.35, technically speaking. All right, divide by 100, you move twice to the left. The point. The hard part is trying to identify where it is to begin with. If you have a whole percentage, just kind of double talk, it should be there to start with, even if it's not written. All right, this one is more obvious. They told you where it is because it was a decimal style percentage to begin with. I'm getting breathy. I think it's my tie. All right? I think my collar chokes off my air supply, and hunching doesn't help, so I'm going to loosen that. All right, nonetheless, we're converting from a percentage, so we are dividing by 100. And again, the effect is to move twice towards the left. So 1, 2, this is 0.698. All right, and if you want, you could stylistically, you could put a 0 in the front of you. All right. This thing is, again, not really, I shouldn't call it a trick question. But look at what it is. It's a percentage for sure, all right? But it's in the style of a fraction. So even if we wanted to pull this trick of just, not really thinking about it too hard, just moving the decimal point twice to the left, we would have to convert this first to a fraction. The train of thought would be, all right, you take the fraction and convert that to a decimal first, all right? Then we convert this to a percentage, right? There is an alternative. I'll show you both of them, all right? But here's what intuitively occurred to me. I'll put it up here. If we decided to go with this train of thought, just to pull the trick that we had been doing here, then you would take 1/2 and you would divide the top by the bottom, right? This is this diagram again, all right? If you're going to convert from something in the style of a fraction, starting here, dot, and you're going to a decimal, you divide the top, the numerator, by the bottom denominator. Right? So a lot of times what I would do is just simply draw the box adjacent and drop the top in here and put a point, and then throw in zeros to get started. All right, and you'd say, all right, 2 does not go into 1, it's too small. Placeholder, dot just above where it is here. 2 goes into 10 exactly 5 times, right? Which makes this 10, and it terminates, and therefore you don't need these extra zeros then. So 1/2 is 0.5, and then if you convert that to a percentage, from a percentage, I should say not to it because it already is. This is already a percentage. If we're converting to just a regular decimal, we would be dividing by 100, and the effect would be to go like so. 0.005 is the answer here. 0.005. Right? Which, if again you like, you could throw in a 0 up in the front. If you did it a little bit differently, right, the alternative would be, let's see, taking 1/2 and dividing by 100 like this, right? Sort of the direct path from a percentage to just a fraction here. Right. You're starting with a fraction, you're going to a percentage, so you're going to divide by 100. Right, pardon me, I'm double talking here. We are starting with a percentage, and we are going to something that is purely a fraction first. Right? So we are going to divide by 100, and then I will convert it to a decimal. Right? It's kind of a roundabout way of doing it. All right? You may or may not remember, so let me give you a little sort of mnemonic device. When you divide fractions, right, there's this procedure: keep, change, flip. %, we want to convert it to something that is no longer a percentage. So I'm going to divide by 100. When you divide fractions, you must keep, change, flip. I hope that is visible, so let me pull this slightly. Hope that's not too dark. Does that help a little bit? Keep, change, flip. That means keep the fraction as you see it, change the operation to multiplication, and then compensate by flipping what would be 100 over 1 to 1 over 100. Right? This is known as a reciprocal. Fancy way of saying fraction flipped upside down is a reciprocal. So 1 over 100. Then it's more or less straightforward. All right, forward. 1 times 1 is 1, and 2 times 100 is 200. Now you have something that is purely a fraction now. It is no longer a percentage because we did the division. If you wanted to convert this to a decimal, which is what the problem really wanted, all right, then you could do this procedure of dividing the top by the bottom now, at this point, which means that you would end up with this. You draw a little box next to it, and then put a 1 in here, and throw in some zeros to get rolling. Pun intended, right? You turned that off. And proceed. 200 doesn't fit into 1, it's too small, decimal point. 200 doesn't fit in 10, 0, too short. 200 doesn't even fit into 100, 0, too short. But 200 definitely fits into 1,000. How many times? 5. Right? Which is 0, and you get the same answer. Right? Ultimately, you will get to the right answer, directly or indirectly, by whatever preference you have in terms of procedures. Just, again, convince yourself, if you are starting with a percent, regardless of what is sitting in front of it, right? If it's a percent and you're going the other way, you're either multiplying by 100. If you're starting from either one of these and going to a percentage, you are dividing by 100. Pardon me, starting a percentage going here. I'm not even looking at my own arrows here. That is an arrow point, right? From, divide, to, multiply, right? From, divide, to, multiply. Right? Pay attention to the arrows, right? And the dots. Oxygen. oxygen would be great. I don't know why I can't breathe anymore. It's my camera. I keep having to hunch, right? And I can't do anything about it, unfortunately. Right? This is more or less simulating if you were in a classroom, you'd be sitting, right? Right. That's the view. I would be standing up straight, though. Okay. All right. Let's do this word problem. That's an example of translation here. I'm not going to do number 5. I just want to do number 4. All right. It says, according to the U.S. Department of Agriculture, in 2014, the United States produced 264 million pounds of cherries. Right? And of these, 182 million came from Michigan, 36 from Utah, 26 from Washington, and 20 million were from other states, non-descriptively. All right, determine the percent of cherries produced in each of the following: Michigan, Utah, Washington, and other states. All right, this is an example of where you may rephrase a little bit. You noticed I didn't read it exactly. I sort of edited as I was reading. At least if you have it printed. Here's what you can do. Remind yourself of a couple of things. All right. There's a model to borrow. And this is it, right? A percentage can be calculated from any total. It doesn't have to start out over 100 is what I'm getting at. Ultimately, if you want to express something in terms of a percentage, that's what you're converting it to, something out of 100, but it doesn't have to start that way. Right, you notice that in this problem they didn't mention 100 at all. All right, what they did tell you are these quantities. They said that there's a total, all right, and the total is 264 million. I'm going to spell it out in English, million. All right, and then it tells you after that in Michigan, that they produce 182 million. And in Utah, looks like 36 million. I'm running out of space, so I'm going to put this next to it. Washington. Land of the apples, 26 million. And then other. $20 million. They have chosen, the author of this problem, not to write the quantity, million, as it would be. Remember, a million looks like this. 1,000,000,000. 6 zeros after a 1. They just simply use the word million. And since everything is expressed using that word million, don't even worry about these zeros. You can, I would never fault you for doing that. It's being very formal, right? But the point is that if everything is written in terms of a million, it's kind of sparing you from having to write those extra zeros, which can get a little cumbersome because there's 6 of them, mind you. Right? Anyhow, the model that you want to employ is basically this, right? Whatever this quantity is over the total, all right, is going to basically be a percentage, right? Regardless of what this number is, as long as it is in fact the total though. Regardless of whatever this unique figure is, 182, 36, 26, or 20. So once you divide them, right, you get a decimal, and then you can convert the decimal to a percentage formally. So you can calculate, the percentage can be calculated from any total. It doesn't have to start out as 100. You're going to convert it to something that technically is out of 100. Right, so in this first instance, for Michigan, out of the total, it would be 264 out of 182. Again, you don't have to bother putting the zeros. It isn't wrong if you do that. But look at it this way. If this is a million over a million, that means comma 0, 0, 0, comma 0, 0, 0, 0, 0, 0, comma 0, 0, 0. The mental math shortcut that you would employ, right, at least if you're aware, is that you could cross out pairs of zeros without even really worrying about the GCF legal reason why, right? So rather than spell out 6 zeros, you just have the word million divided by a million. Something divided by itself. You just have to zero in on these numbers here, right? As long as it's consistent that way. My blue is kind of sucky today. Sucky blue. That should be the name of this color. All right. It's a damn shame. I like blue. All right. Anyhow, you would now take your calculator, all right, rather than reinvent the wheel, and type in 182 divided by 264. So you'd see something like that. I'm sorry about the glare. And it gives you a decimal, right? 0.68939 repeating, right? You would have this 0.6893 repeating, a bar notation over the 93, because it would be 93, 93, 93 into infinity, right? We already went through the exercise of converting from what is essentially a decimal, right? We've taken what is really a fraction here and converted it to a decimal. Now, if we wanted to, we can convert this to a percent, formal percent, right? How do we do so? When you convert to a percent, you're either going to multiply or divide. Well, which is it, right? If you convert to arrow point a percentage, regardless of what you start with, right, you're multiplying by 100. In the case of converting from a decimal to a percentage directly, it's easy to do because you just have to multiply by 100, and the effect is moving the decimal place twice to the right. That means that this is really 68.9%. Now, if you did, that's just for Michigan, right? That's accounted for. We're going to write similar fractions for these others, right? For Utah, it's just changing what the top number is. So in this case, it would be 36 out of 264, just to shorten it, right? And in the case of Washington, it would be 26 out of 264, right? Having done this simplification and not really worrying about it. Other is 20, right? Other states, which may be several. 20 out of 264, right? Now there's a little bit, if you're looking at this in the book at all, they rounded a little funny. They didn't take into consideration that this was repeating, but it's excusable, it's negligible, all right, in the big picture, all right? What you should get in each of these cases is the following. 36 divided by 264, that's a fraction, and we're going to convert this to a decimal, is 0.136, all three digits repeating. So it's 136, 136, 136 forever and ever and ever. All right. So if you then multiply by 100, the effect would be that you scoot the decimal point over twice to the right, right? Which means you would end up with what? Approximately, let's see, 13.6%. Okay. In the case of the next one, Washington is 26 over 264. All right, you would get this as a decimal, a precise answer. You would get 0.09, and then it repeats after that. 8, and then 484848. Right, which if you then multiply by 100, again, the shortcut effect is that it just scoots the decimal point over twice to the right, which means this is approximately 9.8%, right, for Washington out of the total cherries. Right? This is rounded really correctly, all right? Not rounding before, but rounding at the end, right? A lot of time, my instinct is avoid rounding until dead last, because if you round it intermittently, it will compound an error. So try not to do that, right? Even if the book did it, right? 20 divided by 264 would give you this. 0.075, and then it's a bar over the 7 and the 5, because it would be 75, 75, 75 repeating. Again, if you multiply by 100 to formalize it as a percentage, the effect is to scoot this over twice, and then what you end up with is approximately 7.6% if you round now. All right, so 68.9% of cherries in the United States production come from Michigan, apparently. I didn't know that. 13.6% of cherries in the United States production come from Utah. 9.8% from Washington, and from a bunch of other states, not really specified, it'd be 7.6. Perhaps Jersey even. All right, I wouldn't be surprised, right? I don't know if they're primed to grow here, but perhaps they do. Tomatoes. Need more water, sorry. Next. Right, I didn't do 5 because to me it was just more or less redundant. So let's look at 6. All right, number 6 incorporates a formula. In the packet, as I alluded to, there's a page. It's the way I have it here is the top page. All right, that has that's last time. There's a page, second in this, that just reiterates the formula I had given you maybe a class or two ago. The percent of change formula. All right, this top thing here. So let's do an example that utilizes that. All right, and number 6 would seem to be the perfect example. All right, McDonald's stock. Should be GameStop, right? Since everybody's talking about it. Okay, just a quick refresher. The percent of change is basically expressing a degree of change that is a change that is increase or a decrease, all right, as a percentage, because people like percentages. Now, think about whenever you've had a test, right? On a test, the test doesn't necessarily have 100 questions, right? It may have 20, but you could still express a score as if it were out of 100, right? With like a lot of my tests were always like 20 or 25 questions. So you would just upgrade it to a fraction out of 100 rather than a fraction out of 25 or 20 or what have you. All right, anyhow, if you want to express a degree of change that is either an increase or a decrease, something went up or something went down, as a percentage, that's just to give people warm, fuzzy feelings, really. All right, and there's a formula for that. All right, it basically is this. There's an order of operations that you really must conform to, but it is this basic idea. There's going to be a subtraction, some kind of a difference that you must do first, right? Subtract if there's a difference. And then divide, that's this line here, by the original amount, whatever it is. So sometimes they would say initial amount. Okay, so if I'm sticking with that labeling, initial as in the original starting amount of something, the difference would be this. It would be the final amount minus the initial amount. As long as you're comfortable with that phraseology, right? That's what this difference is. It's a final amount, whatever it is, and some initial amount. Now, and then as an afterthought, you would multiply by 100. All right, that is what makes it a percentage. Right? What will happen, all right, at least if you do things according to plan, all right, is that you will see either a negative number, all right, or something would technically be a positive. All right, if the calculation produces a negative, it would verify something that you would maybe infer anyhow, that there is a decrease. All right. Whereas if it's just a positive, then that is an increase. Okay. So associate negative with something going down, and associate a positive outcome with something going up. All right, so in the case of this question about McDonald's stock price, all right, I'm reading here. All right, on May 13th, 2014, the price of one share of McDonald's stock was $103.53. Gotta use green here because it's money, right? I'll put the date here, it's a little silly, but May 13th, never mind the year, it's irrelevant, right? The price of McDonald's one share was apparently $103.53. Hopefully that's visible. Later on, in October, so 10/16, the same share was worth $89.91. Somebody ate too many hamburgers, all right, and wasn't happy, all right? Their value went down. Anyhow, from these two features, you could infer without even doing a calculation, right? This is earlier in the year, this is later in the year. This is the price earlier in the year, this is the price later in the year. What did it obviously do? It went down. So if you're going to stuff them in the formula that they have given you, this is what you would say is the initial price, and this is the final price. So the way that that would be written and incorporated into that would be like so. It would be this number in front, even if that seems a little counterintuitive because it's smaller, right? what is going to happen is that you're just going to end up with a negative, which confirms that there's a decrease here. So 89.91 minus 103.53. And then you will divide by, what was it originally? The initial price was still the same figure, 103.53. All right, times 100 to make it a percentage. I'm going to erase this because I need the space. Okay, remember, you have to do this first, the subtraction. And then you do this division second. And then you do this multiplication third. All right, there's an order of operations. That's why there's this parentheses here, to draw your attention to it. All right. All right, so you're paying attention to the inside of the parentheses. Because you have a top here and you can't divide by two things simultaneously, you logically have to combine these first. All right. Anyhow, the result is this. Right, you should end up getting a negative 13.62, right, having done the subtraction, over 103.53. And then when you do this, you end up with this figure. Just coincidentally, it's a similar looking number. Negative 0.1316. It's somewhat probably rounded. And then times 100. Remember the shortcut, even without using a calculator, when you multiply by 100, it just scoots this decimal point over twice to the right. So you end up with negative 13.1. If you rounded it, about negative 13.2%. All right, which confirms, again, negative means it went down. But you don't need the calculation, it just validates. You would understand that intuitively, by the fact that the number started higher and it went lower, right, over the course of time. The next example, 7, is about markup, right? So again, there is a formula for markup. If you want to use it, I included it. All right, this is either for markup or markdown. Selling price minus dealer's cost divided by the dealer's cost. It's a very similar looking thing, all right? It's just using different labels, if you will, right? Now, let me give you a little background here. I'll open a window. Hopefully that's not too dark. All right, a little background about markup. I had alluded to this maybe a couple of classes ago. What is markup? Markup is essentially an added cost, an additional sum, all right, tacked onto the price of something. All right, this is so that a store can make profit. All right, and it would explain All right, now if you say, for example, this calculator ranges from like $10 to $20. Why does it cost different things in different places? Because different stores will have a different markup. They bought this from the manufacturer, all right, or maybe perhaps from some third party, and they paid whatever is the basic price for it, right? But they want to make money because they're a store, right? So they will, to varying degree, put on an additional sum onto the price, which they pass on to you, the consumer, naturally, all right, so that they can maximize their store profits, right? It's not really malicious, it's just what they do, all right, to have a store, all right? Anyhow, if you go to Staples, right, you might pay $20 for this calculator. If you went to Walmart, you might pay $15 for this calculator because they have different markup prices. The additional cost that is extra, the additional price that they tack on. Right? Anyhow, if you wanted to calculate that in terms of a percentage, you could figure out what the difference is. Again, just to summarize, over, and I'm just changing the labels here, the original amount, all right, and then multiply by 100. This will express it as a percent of markup instead of calling it a percent of change. Up. I swear that's an up. All right. The way that they have chosen to label the difference is to refer to it this way, intuitive to the set of circumstances. So the selling price, instead of calling it final, right, minus the cost, right, that's what they paid for it. The original amount, instead of calling this initial again, is to call it the cost, right? That's basically what they pay, like a manufacturer suggested retail value, you know, I suppose. You're talking about cars, right? So you're going to subtract two things nonetheless, divide second, and then multiply by 100. All right. As to the specifics of the problem, all right, I'm going to read this. Haldren hardware stores pay $48.76 for glass fireplace screens. All right, that's an interesting item. They regularly sell them for $79.88. At a sale, they sell them for $69.99. Determine A, the percent of markup compared to the regular price. And then part B, the percent of markup on the sale price compared to that different number. So you're going to do the calculation twice is the bottom line. Right. If these are the figures involved in example 7, for A and for B, we're going to use the same formula twice, but here are the conditions in each case. All right. For both of them, the store paid $48, you notice it's lower, and 76 cents, right? In either case, that's their cost. This is the quote-unquote cost of the item, right? What they're selling it for is different though, right? Their regular price in part A here is $79.88, right? And apparently no one was buying them, all right? Because they figured, rip off, you know? So, frick you, I'm going to a different store, right? And then they said, okay, we better lower the price. So then their sale price was $69.99, right? Here's a cue as to the fact that there's a markup here. This is what the store paid, this is what they're charging, right? After this didn't work, right? So they went about $10 lower, not quite, maybe a little bit more, right? No, a little bit short of $10, right? Anyhow, forgive them, they're trying to survive, right? This hypothetical Haldren hardware store, right? Anyhow, so they're gonna, if you want to calculate the markup here as a percentage versus the markup here as a percentage, you do the calculation twice, all right? So here's how the mechanics of this would work out. Selling price up in front, 79.88 minus 48.76 divided by 48.76 times 100, right? In this instance, right, selling price up in front, 69.99 minus 48.76 divided by 48.76 times 100. And remember, you must do the subtraction first, because you have to have one number on top divided by one number on the bottom. All right, that supersedes anything else. And the result should be these two things. All right, you get 0.63828, whatever it is, times 100. Which has this effect, which means that this is approximately, if I round it to the 10th place is 63.8, it looks like, markup. Right. 63.8 markup percent. That's a 6, I swear. Right. In this instance, if you divided these two, the difference over this 48.76, you get 0.435978, looks like, something like that. All right, again, times 100. The effect of multiplying by 100 is to scoot this over twice, which means that this would be 43.5 approximately percent markup. All right. So, as you can see, because they're what were they selling again? Glass fireplace screens were not, people weren't beating down their door to buy them, all right? So they lowered their sale price, all right? And as a result of that, the markup was a little bit lower than what they were originally planning, okay? Let's see. All right, let me walk you through these number 9, number 10, and 11. All right. I'm going to skip 8. All right. A class or two ago, I was telling you there are these things called percent equations, which is funny because they all involve a percent one way or another. But just to reiterate this point, there are times when you're looking for what is referred to as the part. There are times when you're looking for what is called the base. And then when you're looking for the actual percentage. Right? There were equations, but they involve varying amounts of algebra and arithmetic. A part equation is identified by this statement. Is what? If you see is what in the sentence, chances are you're looking for the part, which is a part is a portion of the whole, of the original amount of something. It's usually smaller. There are instances, depending upon the percentage being greater than 100, that it might be larger. All right, but it usually is smaller. All right, the base is the original amount of something, and it's usually bigger. All right, you can identify that you're looking for this because you'll see of what in context. All right. percent is the easiest to figure out that you're looking for because it will simply say what percent. You know? All right. So look for is what, of what, and what percent, right, to tell you which one you're doing. Why do you care? Because this involves just multiplying, right? It's just arithmetic, right? Of what is an algebra problem, ultimately, which means that you're going to end up dividing, right? What percent is also an algebra problem, which means that you're going to end up dividing and then multiplying by 100. So this is 2 steps and this is just 1 step, right? 2 things that are very useful to you, right? If you see the word of, immediately translate this to multiplication, whether you use it or not. If you see the word is, immediately translate this to the equal sign, okay? That'll get you rolling if you just look for these features, okay? Basically, number 9, number 10, and number 11 are one of these, each one of the one of these 3 things, right? This is a good exercise in rephrasing as well. Right. Now, if you look at number 9 here, this says a down payment on a condominium home. All right, I'm going to read it to you as it is actually written, but then I want, again, I can't stress the importance enough. Take a little artistic license. You don't have to tolerate something. It could be written poorly. All right. Textbooks are not all created equal, and sometimes somebody wrote something for the sake of confusing you. So you have to take it and then go, I'm going to write this more clear. All right, should have been written clear to begin with, but you know, this is a textbook, so whatever. Read this entirely, all right, and then grab the essential. I'll show you how I did it, all right? Okay, this says, Melissa wishes to buy a condominium home. Maybe I'll project it. You know what? Just emphasize that point. All right. I'll do that. All right. Here it is. And I'll move this. All right. Melissa wishes to buy a condominium home for $189,000. Right? To obtain the mortgage loan, she must pay 20% of the selling price as a down payment. Determine the amount of Melissa's down payment. Now, let me rationalize this. If she's making a down payment, would you assume that it's a smaller amount than $189,000? Or a larger amount, right? I would reason that it's going to be smaller, right? So if you're looking for a portion of some original amount, then the type of equation that you're going to use is the so-called part equation, all right? All right? Which means maybe you could rephrase this, all right, to just its bare essential, all right? There is, if you notice in here, 20% of the selling price, which is that number, right? So, 20% of $189,000, right, is going to be what? It's going to be the down payment, right? Which you could rephrase as, in the form of a question, as if this was Jeopardy, right? Is what? Right? I gotta turn this off for just a moment because of the too much superimposed text here. And now look at what we have, right? We're looking for a portion of the whole, a down payment. And I have rephrased this because I'm old and I'm not scared. Right, to just get to the essential question, 20% of $189,000 is what? That's really all it's asking, all right? It's just doing it in a verbose English way, right? So here's the tricks that I had suggested. Once you've gotten it down to that, start with translating these into symbols. Of, just of by itself is times. Not to digress, but if you saw out of is division. Just of is multiplication. Is equals. So that means that whatever is sitting in between here is going to be multiplied. And whatever's over here, what is the down payment? You could just use a letter just to fill a void for right now. N for number, Or just leave it blank if you like. Then there's this 20%. You could translate this percentage to a fraction if you like, or you could translate this to a decimal. I think people are probably, because they're going to use their calculator, probably more inclined to make this a decimal, because you know that when you're converting from a percentage to a decimal, you're just going to move the decimal point twice to the left, making this 0.20 times that which you just enter into your calculator, and it spits out the answer. But don't be intimidated. If you make this a fraction, all right, you're still dividing by 100, but you're doing it in a more literal way, which would look like this. It would be 20 sitting on top of 100. This bar means divide, right? The advantage to doing that when you're talking about things that are financial is that financial loans and whatever else are usually nice round numbers, which means that if you have zeros in the bottom here and you have zeros in the top here, you could trim it, right, with mental math skills. All right, for example, 2 zeros here on the bottom and 2 zeros here on the top leaves you with the same relationship as if you just multiplied 20 times 1,890. You will get the same answer as if you multiply 0.20 times this larger number. All right, anyhow, what do you get as an answer? You get $37,000, which sounds about right for a down payment on a house. Not that I have a house, I have an apartment, but nonetheless. $37,800. Okay? This is, again, a couple of things incorporated. Translating from a percentage into something that is actually usable, either a decimal equivalent or a fraction equivalent. Translating words into operations and symbols, all right? And not being afraid to just rephrase it a little bit within reason. Right? All right. Let's look at the next one. Turn the projector back on. Let's move this. That was number 9. Let's look at number 10. Still rephrasing where we can. I'll scoot this up a little bit. Here's number 10. All right. Scholastic chess membership. All right. The U.S. Chess Federation has about, I'm going to circle some numbers here, 77,000 members. All right. Of these members, about 28,000 are considered scholastic members, meaning they are in school. All right, from kindergarten through college, all right? They're telling you flat out here, what percent of the members, and that's total members, to rephrase, are scholastic, the smaller portion, all right? The part here. If they're telling you what percent, then rephrase it like so. What percent of 77,000 is the part that is the smaller amount, 28,000. Question mark, right? That gets at the essence of what they're looking for, being less verbose. Right? I'm going to turn this off again. My bulb is going to curse at me, probably. All right. we'll do some translation here. All right, again, get in the habit, whether you use it or not, of is times, at least to start with, is equal. All right, so if you see of 77,000, that means you're just going to plop 77,000 in here. And since this smaller part is already identified as 28,000, it's going to be on the opposite side of 28,000 on the right side of the equals. Right? Now, since we're looking for a percent, this is going to be an algebra problem, so we need a letter. Right? To me, it might be intuitive, right, to just put P for percent. Right? So P, the percentage, which is usually a decimal, right, or a fraction technically, times this number would give you this. We're going to solve this algebraically. How do you solve algebraically? It's a little counterintuitive, right? You do opposite operations. And to make it legal, you do it to both sides. All right, that's step one, that's step two. This is the balancing act that is algebra. You can get away with murder in math as long as you're consistent that way. Whatever you do to the left side of the equals, do to the right side. All right, so what is the opposite of multiplying by 77,000? The opposite of multiplying is dividing, but the tendency in algebra is to use this line rather than the colon, all right, with the line through it. That's out of the frame, I think. So, if you divide by 77,000 here, there'll be a cancellation effect by design, because that would leave you with the thing that you're looking for, the P percentage. And then to balance it, you will do that here, 77,000, all right? Now, again, you could just enter this into your calculator immediately, and it will spit out a decimal, no sin in that. But you can sort of prep it with mental math skills, which would be like, take advantage. You see pairs of zeros? Cross them out. This is basically simplifying the fraction by its GCF without really consciously thinking about it, or at least by a very high number, a very high factor. This is like dividing the top by 1,000 without thinking, or writing in 3 zeros, and dividing the bottom by 1,000 without thinking. That's what crossing out these zeros is. The relationship, all right, of 28,000 to 77,000 is exactly the same relationship, regardless of its shortness, to 28 over 77. So you could just type this instead is what I'm getting at. Alright? And when you do, you type the top thing first, 28 divided by 77. It's a little bit faint. And there's your decimal. Alright? Which is this. It's like 36 repeating, right? 0.36, 36, 36, 36 is what you see on your screen here, right? Sorry if it's flat. My wrist is a little messed up from shuffling. 36, 36, 36 into infinity. This is a rounded digit on the end here, all right? Same as if you did this, 28,000 divided by 77,000, all right? You would get the same figure without having to type all those extra zeros. It's the same relationship, that just is taking advantage of shortcuts. All right, so this is not a percentage, right? And if I wrote it out without the bar notation, it would be another 3 here, and then another 6, and a 3 and a 6, and dot, dot, dot. If I'm going to convert this to a percentage, because that's what they really want, you have to remember, when you convert to a percentage, you're multiplying. Not to belabor the point, but if you're converting from a decimal to a percentage, you are multiplying by 100, right? What is the effect of that? The effect is to scoot the decimal point twice to the right, which means that this percentage is about equal to, because I'm rounding a bit, because it's repeating, 36.4%. In this National Chess Club, you know, a good over 1/3, because it would be 33.3 repeating is 1/3, right? Over 1/3 of the membership are kids, for all intents and purposes. Right. Young whippersnappers. All right. All right. Let's see. All right. One more question to illustrate the other type of the three types of percent equations, and then we will stop. All right, let me turn the projector back on. Thank God for that, right? Sometimes it is very helpful. Thank you, Kodak. And your cheapo camera. Projector, I really should specify. Here's problem 11. Right. The population of Germany. Right. Right. About 10,400,000, or about 13% of Germany's population is younger than 15 years old. Right? What is the approximate population of Germany? Without saying the words explicitly, they're asking you, what is the total population? All right? So of the three types of percent equations, it's the base equation. Right? So you would see, I'm going to rephrase this now. Right? 13% of what, which is standing in place of the total, is this number, 10,400,000. Right? Again, don't be afraid to rephrase something to its bare essentials within reason. All right? 13% of what is 10,400,000. Takes a little bit of experience, but it also takes a lack of, well, a little bit of courage too. I know that for all of us, all right, anyone who has gone through school, all right, especially if it's not your favorite subject, you've probably been battered emotionally a lot, and people tell you, you don't know what the hell you're doing, all right? You will, right? But you can't be timid, right? You can't be a bull in a china shop, but you can't be timid either. There's an equilibrium that has to be met, right? Anyhow, we have techniques. There is a plan, all right? And here it is, all right? Of is what operation, at least to start with? Multiplication. Is what symbol? Equals. A total is the original amount of something, all right? I.e. a base, if you want to be technical, all right? And it would be identified by of what, right? All right, we're rephrasing. 13%, I'm going to, in place of what, the total, whatever you want to call it, I'm going to put a letter, all right? Let's just go with, I don't know, G for Germany, all right? G, und ja. Okay, and then you have this number here, 10,400,000. And then you have this figure, 13%. 13%, again, you have options. You could write this as a decimal if you prefer, or you could make this a fraction if you prefer. Right? I think it's probably easier in this particular problem to go with the decimal equivalent. Right? All right, just to avoid a keep, change, flip if you're a little bit rusty with that stuff. All right? So 13% in the style of a fraction would be 13 divided by 100, right? In the style of a decimal, it would be moving this, actually doing the division, and it would be 0.13, right? So you have 0.13 times this mysterious German population here is that number, the people who are under 15. So this is now good to go. It is a one-step algebraic equation, which means we're going to perform opposite operations to both sides of the equal sign to make it legal, all right? The opposite of multiplying is to divide. What are you dividing by? The number here, all right? So 0.13, for which there will be a cancellation effect. There will be one simplification. And if I did it here, I'm obligated. This is a Zen balancing act of algebra, the beauty of it. You will divide by 0.13 here, right? There's no shortcuts really in this instance. Just enter this as you see it, all right? 10,400,000 divided by 0.13 instead of 13. Right? And the effect is this. You'll see that the German population, at least probably the time this was written, is only 80 million people, right? It's quite a lot of people, granted, all right? But compared to the United States has something like 300 million people live here, right? And in China, it's like over 1 billion, right? So that's that, right? People. Okay, so we are done, basically. Let me just remind you of a couple of things, and then I'll stop. All right, for homework, especially if you're a little behind, right, make sure you're doing your MyLab. Right, if you're current, you would be on section 10.1. Right, that was what was just discussed today. All right, somebody sent me an email and they said, all right, well, what are the assignments? The assignments are everything that has been occurring to this point, right, day by day. So if you have the physical calendar, which is also online, all right, as soon as you open our Canvas course page, we covered section 1.1, 1.2. Is this the right section? Yes. All right. 1.3, 6.3. All right, we did 6.4, and now we just did 10.1. All right. On Tuesday, I'll tell you what's going on with the test. All right. I don't really want you to worry about it. All right. I want you to do your homework. All right. You have until the evening of February 9th in order to complete these assignments. All right. So make sure that you do that. That is where most of your grade is coming from. Okay, so please make sure you have an account, all right, and that if you got to catch up now if you're a little behind. Okay, all right, so I'll see you again on Tuesday. All right, be careful out there.